This is my CR-10. It's old, outdated and slow. So today we're fixing that and making it a little bit more aggressive. In part 1, we gave this thing a new tool head and swapped out its brain. Today's objective is quite simple. We're replacing the entire frame, all of the steppers, basically all of the mechanical components, swapping out all of the old power supplies with something a little bit more beefy, adding the Cartographer Probe, and finally dialing in input shaping and finding out how fast this thing can actually go before it starts to complain. Now, while some of you were busy discussing my very unique taste in music, I was busy slapping together a dodgy but temporary enclosure and forcing this printer to print its own replacement parts out of ABS. You better start printing. Well, the printer wasn't happy about that and put up quite the fight. That's not good. This chip is fried and I've got no more 12-volt power. You've got to be kidding me. But the joke is on the printer, because all of the parts are done. Now, a lot of you had some very good ideas on how to make the printer even faster, and may have accidentally convinced me to turn this 3-part series into a 4-part series. Well, that all depends on how well this printer performs at the end of this video. I guess it's time to disassemble this thing and hope I didn't make a mistake. Let's rather just skip through the whole disassembly thing. Now, just out of curiosity, I want to compare the weight of the old frame with the new one. That's just over 2.2 kilograms. Now, something tells me if we want to sling a 300 by 300 millimeter build plate back and forth at high speeds, we definitely need to add some weight. One way of doing that is by swapping the original 2040s for much bulkier 4040 extrusions and giving the frame a bigger footprint. But I'm not stopping there. I'm also adding a full support gauge to help handle the forces of the bed slinging around at high speeds. And the best part, it doubles as the enclosure structure as well. And if you're wondering, out of all of the original frame pieces, I'll be only using these. Now, to cut all of these to length, drill some holes and add some thread. Now, if you're wondering what this thing is, now it's a new jig that I recently made with the sole purpose of cutting aluminium extrusions perfectly square. And at the moment, it's doing it beautifully. Now, if you want me to show you how to make your own, let me know in the comments below. Now let's see how much weight we actually added to the frame. Now this scale has got a 3 kilogram weight limit, so I'm gonna have to weigh it in batches. Now let's hope that the extra 5 kilograms will keep this thing stable. Now the next step is to assemble this frame. Now that is absolutely perfect. Now, to prevent this frame from skating around and sitting directly on the extrusions, I temporarily added these rubber feet to the bottom. Now that will definitely change once I build the electronics cabinet, but for now, that will do just fine. I already went ahead and cleaned and prepped all of the 3D printed parts, so now it's time to start to assemble them. First up, the Z-axis. Now the Z-axis isn't anything revolutionary. I took some inspiration from the LH Stinger, but I simplified a few things for my own design. For example, the left and right motor mounts and belt tensioners are fully symmetrical. Now I'll be using the stock Creality 4240 steppers on the Z-axis. And just like the LH Stinger, I'm using a 20 to 80 tooth belt reduction, which massively increases the effective torque and the holding force of these motors. And for the belt tensioning, I'm using a toothed idler with about 8 mm of adjustment travel. So far, everything is actually going really well. Everything fits, but that one question is lingering in my mind. Will it work? Now for the Y-axis. The Y gantry runs on dual MGN 12 rails with 4 carriage blocks, carrying a custom carbon fiber plate that I optimized using FEA for minimum weight and maximum stiffness. The axis is all-wheel drive, powered by 2 LDO superpower motors. The rear motor mount is fixed and the front mount doubles as a tensioner, pulling the motor forward using an externally adjustable M6 bolt. Now everything is aligned so the belt runs directly from the motor pulley to the gantry with no extra idlers. To make it work, I just had to cut a few notches for the belt to clear and add a cover plate to protect the belt from any sharp edges. And finally, to ensure that the motor's power isn't going to waste, the motor shafts are supported in double shear for extra rigidity. Wait a minute. This isn't carbon. What on earth are you doing? What do you mean? I'm making a carbon fiber plate. You idiot. If you want the real deal, PCBWay is the place to go. PCBWay isn't just about PCBs, although they do those insanely well. They also offer CNC machining, 3D printing, laser cutting, and a whole range of manufacturing services. The only thing that you need to do is to upload your file, select the quantity, choose your material and finish, and you'll get an instant quote within seconds, with your parts delivered right to your door. For this project, they supplied the gantry and build plate, laser cut from carbon fiber pre-preg, and as you can see, they are definitely the real deal. If you want to see the quality for yourself, check out the link in the description and you'll get $5 off on your first order. Use this. Ooh, fancy. Now before I go and slap this onto the printer, let's first see how much weight I managed to shave off using these carbon fiber parts. I'm not just going to compare the plate, but the entire Y gantry. Build plate, heater, and all of the mechanical bits. Now the old setup comes in at just over 2.4 kilograms. Now for the new gantry. Well, it looks like we barely managed to shave off 400 grams. I really hope that this will be enough. Otherwise, I might just have to ditch the magnetic base. Damn, that's heavy. Let's test it. Ooh, that's smooth. Now, time for the belts. To attach the belt to the gantry, I'm using these aluminium tensioner blocks. They sit inside this pocket in the carbon gantry plate. That was made by bonding this U-shaped carbon block to the main plate using high temperature epoxy. I really hope this tensioning system works. It works so good. Oh, that's a relief. Now to just add the silicone heater to the carbon plate, as well as this brick of a magnet base. Since I'm using the Cartographer Probe, I won't be using the springs anymore. Instead, I'm switching to the solid carbon fiber spacers for a fixed, rigid setup. And to keep everything clean and secure, I took some inspiration from the LH Stinger again and designed this cable support bracket. And with that, the Y gantry is finished. Now next up is the X-axis. The X-axis will be mounted to two MGN 12 rails. Now mounted to the two MGN blocks are two separate brackets, one on the left and one on the right. Now the left bracket is the motor mount. It features double shear support for the LDO speedy power motor plus some space on top for the limit switch. Now the right bracket acts as the belt tensioner with an integrated tensioning wheel, so the adjustment happens here instead of the tool head. And to secure the belts from the Z-axis to the mounts, I once again took some inspiration from the LH Stinger and used a similar clip style system. Now to add the tool head. Now the tool head is exactly the same as in part 1, just with new 3D printed parts to match the updated color scheme. And this time I will finally be adding the Cartographer Probe. And to finish it off, a custom pass-through plate. It has space for the umbilical cord, CPAP tube and for the water cooling lines. And the best of all, it also doubles as the mount for the parts cooling fan. Now with all of the mechanical components finally done and out of the way, I just need to hook up all of the leftover electronics, swap out the old power supplies and drivers, perform a magical smoke test, no smoke, and update the printer config file. And now we should technically have a working printer. Now let's see if the hot end and bed heater actually works. That's so scary. The bed heater is actually faster than the hot end at the moment. Now that we know that the hot end and bed heater is actually working, let's see if we can home the printer. Now that we know the printer is working, let's set up the Cartographer Probe. Something that should have taken about 5 minutes ended up taking over 8 hours. Turns out my pre-flashed probe didn't want to cooperate, so I had to flash it again and again and again and again and again and again. And after attempt number 153, it finally decided to work. What? And it was worth every single attempt. I mean, just look at this. Now that is amazing. Now let's try and print something. Well, it definitely works. But before we jump into printing Benchies, I first want to do input shaping and maybe do 1 or 2 speed tests. After part 1, I did run input shaping just to get the best print quality for all of these rebuilt parts. Now for those who are curious, here's the results. Now to test it again. Now since the beginning of this build, I always had a feeling that there's going to be some sort of bottleneck. Either it's going to be the hot end or the y-axis. And now I'm finally going to find out which one it actually is with some speed tests. First up, maximum flow rate. Now for this test, I'll just be using the built-in test in Orca Slicer. I'm going to be extremely optimistic about this. Now there's defects in the front and at the back, but the first one started here in the front, so let's measure that. First defect is like just over 35 millimeters, so let's go with 35. Now 35 millimeters equals a flow rate of 27.5. That would give us a print speed of 220 millimeters per second. That's So I ran the test again, and this time I got a slightly better result, a flow rate of 31. So the CR-10 can technically maintain a print speed of 248 mm per second, and I'm quite sure that the y-axis will definitely beat that. To test the motion system, I'll be using Andrew Ellis's speed test. I'm going to start with 400 mm per second and 6000 acceleration. Now I'll keep the speed constant for now and only increase the acceleration. Now we're currently testing at 400 mm per second at 50k acceleration. Now keep in mind, that's a 2 kg build plate. I don't know about you, but according to me, that's quite impressive. Now 50k is nice and all, but pretty much useless when it comes to printing. So next up, I'm gonna try and up the speed. Well, turns out increasing the speed was a bit too much for the Y-steppers. No, that definitely didn't work. So I decided to increase the amps from 2 amps to 2.2 amps and to add some water blocks to them, just to be on the safe side. So the printer is currently stable at 500 mm per second and 25k acceleration. So I think it's safe to say that I need a new CR-10. So here is the maximum stable speeds and accelerations I ended up with. Now that we know the limits, it's time to put it to test. It's Benchy time. Now I'm first going to print a quality Benchy, one that I can compare to the Benchy from part 1. I'm going to print all of the Benchies using the same quality and strength settings, only adjusting the speed settings. I started out with these settings and clocked the Benchy in just over 20 minutes. I then kept adjusting the speed and acceleration and printed a couple more Benchies until I landed on these settings, which gave me my fastest quality Benchy. Oh, sub 12. Just when I thought it can't get faster with that quality. I mean, for sub 12, that is not bad. Well, I'll let you be the judge of that. Now that we know it can actually print nicely, let's ruin that and go for speed. I'm basically setting everything to the maximum, definitely beyond what the CR-10 is rated for. So to compensate for that, I'm also increasing the nozzle temperature. Now let's see if we can print a Benchy a bit faster. With 14 seconds to spare. My first ever sub 10 Benchy, and it looks not too bad. Better than I expected. Now I did try to go even faster, but the y-axis just couldn't keep up and started to lose steps, and increasing the motor current didn't really fix it. But to be honest, I really didn't expect a sub 10 Benchy, especially from a bed slinger this size. So for me, that's definitely a win. But we're still not done yet. I still need to add the enclosure, fit all of this into this, and somehow also find space for this heater. But before I do any of that, I first want to give this thing a more suitable hot bed. Improve the y-axis and see if I can get a sub 6 minute Benchy. Come on, you can't be serious. Now if you want to build this printer for yourself or use any of the parts in your own build, I'll have all of the files available. Just look for the link in the description below. Just keep in mind the design is not finished yet and it will definitely change over time. Thank you to each and every one of you for watching this video, and a special thanks to everyone who waited 3 months for it. Now the next video should be out a lot sooner.
You sure about that?
Well, I really hope so. Now if you enjoyed this video, please give it a like, and if you want to see more, make sure you subscribe. Until next time, thank you for watching.